Section 4.3, Solving Systems of Linear Equations in 3 Variables. When you have 3 variables, that means you are going to have 3 equations, each containing an x, a y, and a z. Make sure you number your 3 equations so that you can keep them straight, because you can only add 2 equations together at a time. And when you do that, just like before, we're going to eliminate either x, y, or z. So it does not matter which 2 equations you add together first. I am going to use equation number 1 and equation number 2. And it does not matter if you eliminate x, y, or z first. Just choose one. I am going to eliminate x first because they happen to be exact opposites. So here I have my 3 original equations. I'm going to add equations number 1 and equation number 2 together. And when I do that, my x's cancel out. Negative y plus 2y is 1y. Negative 2z plus 1z is negative 1z. And 4 plus 1 is 5. That is new equation number 4, so number it number 4. Now I didn't use equation number 3 yet, so I must use equation number 3, which says x plus y minus 3z equals 11, and either equation number 1 or equation number 2. It does not matter which one I use, just pick one. And I'm going to use equation number 2 because the x's are already exact opposites. And if I eliminated x in the first 2 equations, I must eliminate x in the third equation as well. So that's why I am picking equation number 2, so they will cancel out. When I add them together, my x's cancel out. Y plus 2y is 3y. Negative 3z plus 1z is negative 2z. And 11 plus 1 is 12. That is new equation number 5. Now that I've eliminated x in all 3 equations, I can eliminate either y or z by adding equation number 4 and equation number 5 together. Now again, it does not matter if I eliminate y or if I eliminate z. I just need to pick one. And I think I will eliminate y. But to do that, I need to make my y's exact opposites. So I need to multiply equation number 4 by negative 3. Every single term, both sides of the equal sign. So that gives me equation number 4 as negative 3y plus 3z equals negative 15. Equation number 5 did not need to change at all in this case. Sometimes you'll need to change both, but in this case we did not. Now when I add them together, my y's will cancel out. 3z minus 2z is 1z, and negative 15 plus 12 is negative 3. So I just solved for z. Now to find y, I can replace z into either equation number 4 or equation number 5 and solve for y. Number 4 looks a little simpler, so I am going to choose equation number 4 that says y minus c equals 5, and I'm going to replace z with negative 3. That gives me y plus 3 equals 5. Subtract 3 from both sides of the equal sign, and we get y equals 2. So now I found z and I found y. To find x, I plug them both into either one of the first three equations. Does not matter which one. I pick one, and then I solve for x. And I decided I am going to use equation number 1. So, in equation number 1, I'm going to replace y with 2 and replace z with -3 and solve for x. This gives me x minus 2 plus 6 equals 4. Combine like terms, x plus 4 equals 4. Subtract 4 from both sides to get x by itself, and we get x equals 0. The ordered triple is 0, 2, -3. In that order, x, y, z. Make sure you list your ordered triple in alphabetical order. X is first, y is second, z is third. Final solution. The system to the equation is the point of intersection of the three lines that has coordinates 0, 2, -3.